This is edenstrength.co.uk, and today's video is an introduction to plyometrics. We're going to talk about the basic principles and then go over some beginner and intermediate exercises. Now, I might not be the best jumper in the world, but I can teach you a thing or two about how jumping higher can improve your performance on the field. Now, resistance training focuses on the muscular and nervous system adaptations necessary for the development of power, which is defined by the NSCA as a given force multiplied by the velocity of the movement. Take a look at these barbells and racks behind me. They might be beautiful, and although you can increase your rate of force development through ballistic or resistance training or Olympic training movements, research suggests that plyometric exercises are an effective way to improve jumping performance and increase your rate of force development without the heavy loading associated with resistance training. This is because plyometrics focuses on the speed element of power training, and in turn helps us translate our strength gains into improved athletic performance. At the end of the day, being quick and making use of the stretch shortening cycle is integral to athletic performance in almost any sport. And before we get started, we should cover the prerequisites of plyometrics. As although resistance training is just body weight or lighter loads, there's still considerable forces placed on the joints. So, depending on what you read, these numbers will differ. But just to be safe, you want to be able to squat at least 1.5 times your body weight for lower body exercises and press at least your body weight for upper body exercises. You also want to be able to squat or press 60% of your body weight 5 times in under 5 seconds. Now that's out of the way, let's take a look at the stretch shortening cycle. The stretch shortening cycle is made up of 3 phases: the eccentric phase, the amortization phase, and the concentric phase. In stretch shortening cycle based movements, the eccentric force, reflex stimuli, and elastic contribution is greater than normal due to the eccentric load. Plyometrics by definition makes use of the stretch shortening cycle. During the eccentric phase, energy is stored. The amortization phase is an isometric contraction, and the concentric phase makes use of the stretch reflex. This is where the amortization phase comes in, as it's integral for it to be as fast as possible, else you waste all that elastic potential. Hoffman in the NSCA's Guide to Program Design puts forward that plyometrics are typically performed with little or no resistance. Overload is applied by increasing the stretch rate or minimizing the duration of the stretch shortening cycle, or increasing the height in drop jumps or depth jumps. Loading can also be added to the beginner exercises such as the squat jump, or to the eccentric phase of more advanced exercises such as the depth jump. The table on screen now is a publication by Ed McNeely in the NSCA's Performance Training Journal. He notes that plyometrics are recorded by the number of single foot contacts with the ground. He states an example of 80 contacts would be 4 sets of 10 repetitions with a two-legged type movement. There's a link to the journal below, and I encourage you to have a look at it. But for now, we're going to go over some exercises. The squat jump is one of the most basic exercises you can use in plyometrics. It can be used in a beginner program or to assess somebody's jumping and landing technique before they progress on to more advanced exercises. As you can see from this landing, the right foot lands slightly externally rotated. This is something you'd commonly expect to see in footballers or any other sport where one side is dominant. Box jump is a simple progression from the squat jump. By incorporating a box, you control the intensity that the athlete's working at. Higher the box, higher the intensity. This allows for detailed programming of the plyometrics. You wouldn't bench at max intensity all the time, so why would you jump at max intensity all the time? Our third progression is the hurdle jump. Similarly to the box jump, the hurdle allows you to control intensity by raising or lowering jump height. It also adds a reactive element, as the athlete has to anticipate the next jump. As we mentioned earlier, Hoffman in the NSCA's Guide to Program Design puts forward that intensity can be increased through increasing the stretch load. The progression on screen achieves this through the addition of a drop jump. For advanced athletes, greater overload can be added through the further increase in drop height. To be specific, literature suggests that depth jumps should be performed at a height of 0.75 to 1.15 meters. Jumps from 0.75 meters allow for the athlete to develop maximal reactive ability, whereas jumping from 1.15 meters develops dynamic strength. Using heights greater than 1.15 meters makes depth jumping ineffective, as the increased height changes the landing mechanism, so neither dynamic strength or reactive ability is gained. Hoffman also points out that loading can be added to the jump to increase intensity, without increasing actual jump height. Consideration should be taken to load itself, as higher intensities may prolong the amortization phase to the extent that energy stored in the stretch reflex is dissipated as heat. On screen is an example of how you can implement augmented eccentric loading in a depth jump. This method places greater load on the eccentric phase whilst allowing for maximal velocity in the concentric contraction, and in turn, optimal increases in force development. So that concludes our introduction to plyometrics. All of these exercises can be used in sports where lower limb power is a key factor. All of the reference work is included below this video. Again, I encourage you to give them a read.